All right, by request 6223. I will be kind of quiet here because I happen to be in a public place right now. So 6223, find the volume of the region bounded by y equals secant of x plus 1 is equal to, and y equals 3. And we are going to rotate that about y equals 1. The first thing you need to do is actually graph this. So I'm going to graph the secant. Let's do this. Do something like this. All right, the secant has this look to it. Normally it starts at a height of 1, but here, because we are adding 1 to it, it's going to start at a height of 2. Something like this. And then you have these asymptotes at x equals pi over 2 and negative pi over 2 technically. Okay. And you want to find the volume of the region bounded by that curve and y equals 3. I'm going to say that this height here is y equals 3. But technically, there are an infinite number of regions bounded by those two curves because there's a repetition of it over here somewhere. But the author's intent is for you to take this region and rotate it about the line y equals 1. So let me go ahead and actually showcase the line y equals 1. Okay, so we're going to rotate it around that. That's my two-dimensional drawing. My three-dimensional drawing, I'm going to go ahead and do off on the side here. So I'll scroll this over. And I'm going to copy that beautiful region there. And remember, it's symmetric, or when you rotate, it's going to have some symmetry there. You're rotating about that line, again, y equals 1. So when you do that, let me change this color to a gray here. Actually, I'm going to keep it black for the moment. So this rotates around. This rotates around. But then you can't really see what happens behind. I should just do this too. This rotates around. And again, you can't see what's behind it. Okay. And remember, in the center there, you have this stuff that's rotating around too. So a typical shell or disc that you would see here, because I'm going to slice vertically, a typical disc would look like the following. Sorry, I'm trying to do it properly. There's a hole in this disc. Maybe I'll use a different color for that. Okay, so that's a typical slice. Now what I'm going to do is go ahead and remember that since that's a slice and it's a disc there, it's going to have an area of the larger disc minus the area of the smaller disc. Those are circles, so that's a pi outer radius squared times a thickness. Remember, the thickness here is a wiggle in x. Minus a pi radius the inner squared, again, times its thickness, which again is a little thickness in x. The outer radius of this, now remember this is a radius from rotation, so let me go ahead and showcase that in red here. So the radius of rotation is from this center all the way to this top. That distance is y top minus y bottom. Top y value is 3, bottom y value is 1. And then for the inner radius, again, I'm going to go ahead and use red here. The inner radius is distance from the radius of rotation or axis of rotation all the way to the inner function there. What you see is the lower function. So y top minus y bottom, I'll actually write that in here. The y bottom there is actually 1. Technically y sub I, but whatever. This is pi times 4 times delta x minus pi times the top y value. In this case, this one right here is going to be defined by the secant of x plus 1. So let me go ahead and write that in there. Technically, it's x sub I. And now you can see both those terms have a pi in common, and technically a delta x in common. I'll just factor that out back. And you're left with 4 minus the secant squared of x sub I. Double check my mathematics there. It is correct. That's the area of this little ith slice right here. I'm going to add up all those slices. There's symmetry here, so actually what I can do is add them up from x equals 0 to x equals wherever these two meet. Right? So we need to find out what this x value here is. So we start at x equals 0 and end at x equals, and I'll just showcase the mathematics here. You're just going to find out when does secant of x plus 1 equal a height of 3. When does secant of x plus 1 equal 3? Or in other words, when does secant of x equal to 2? Or in other words, when does the inverse, of the, or not inverse, but the reciprocal of the secant, which is the cosine, equal 1/2? And that would be pi over 3 from our trig. So we're going to integrate. The total area will equal, we'll leave a little space there for a moment. Integral x equals 0 to x equals pi over 3 of the area of our slice, which is pi times 4 minus secant squared dx. So pi times 24 minus secant squared, and then a dx. Now, I left a little space there because we're integrating here from 0 to that point right there. I need to double that up to get the volume. So I'm going to take 2 of those. The rest of this is just integration, right? Integral 4x. The antiderivative of the secant squared is a tangent. And we're evaluating from 0 to pi over 3. 2 pi times the quantity 4 pi over 3. And then I never really memorize the tangent ratios, but tangent of pi over 3 is opposite over adjacent, which is root 3. Oops, should be a bracket if I'm doing my notation properly. And so this is actually the answer. There's not much else you could distribute through, I suppose, to get 8 pi squared if you want to over 3 minus 2 pi root 3, but not that big of a deal.